Right, let's talk about some reactions of acid anhydrides. The first one being hydrolysis, and we'll first of all concentrate on the acid catalyzed reaction. And again, we'll see that we'll follow the same pattern as we've been talking about. We'll follow the acid pattern, and you can see that the Y group will end up being this group here. There's our Y there. The X group will be OH. You'll see that if we split this up, you'll see that this is going to be X. And here you can see the X group here, which is OH, and this will be YH, where this is going to be Y right here. Alright, so you can see that as Y, and it's got YH. So it is following the same pattern as we've been talking about. Alright, so the OH is replacing this entire Y group, and this Y group ends up with the H from the H2O as well. Alright, let's talk about the mechanism for this now. Now we'll be talking about symmetry of reagents in a minute, but it turns out that in this instance, because water is symmetric, it's not going to matter which C double bond O I actually attack. But for the sake of argument, because I'm trying to follow the same pattern, I'm going to use this C double bond O to attack the H plus. But I want you to understand that in this instance, this particular instance, this will not change the products we get if we were to use the other C double bond O to attack with the H plus in the first step. Alright, so that's going to give us this. And we'll have the H on the O and the positive charge on the C. Now the water will come in and attack the positive charge on the C. This is a pattern we've seen a lot already. In the next step, we know that we want to get this entire group to leave, so we know we're going to have to do a proton transfer, and the proton transfer will be to the leaving group. Now remember, we know what the leaving group is. It's always the Y group, and the Y group is whatever was originally attached to the C double bond O that we're actually attacking. So we know that this is our Y group, and we know that this is the one that gets the proton in the proton transfer step. So the leaving group is always what's going to get the proton in the proton transfer step, and we know that this is the leaving group, the Y group. So we get that, and the C double bond O reforms, and we kick out the leaving group, and we are left with our products. And you can see how it follows the pattern that we've been talking about. And there you go, that's the acid catalyzed mechanism for hydrolysis of an acid anhydride.